Well, a very good morning to you all, and thank you very much for joining us. Here we are on day 3 of MACH Preview Week, which is the second day of our webinar sessions. My name is James Fudge. I'm Head of Events at the MTA, and welcome to this session. For those of you who were on here yesterday, you'll probably know how it works, but for those of you that are new, if you've got any questions at any point, you can use the questions chat function on the right-hand side, or is on the right-hand side of my screen, throughout the presentation, and then what we will do is relay those questions to our presenters at the end. So our session this morning is on Project ELLI, which is all to do with electrification and lightweighting in Industry 4, and we have 2 speakers this morning. First up, we have Rab Scott, who is Head of Digital at the University of Sheffield's Advanced Manufacturing Research Centre. He's been a member of AMRC staff since its beginning in 2001, and after heading up the virtual reality and simulation activities, he now leads on the strategic development and implementation of digital solutions for the AMRC and the wider manufacturing centre. Rab is also the operational chair of the High Value Manufacturing Catapult's digital strategy team. Rab is joined today by James Lindsay. James joined the AMRC in 2017 as a graduate engineer, having previously worked in the automotive industry. He's now lead engineer for the automated assembly team and the integrated manufacturing group, providing technical leadership and development to a diverse engineering team focused on research into automation. James has led Project ELLI for the AMRC, which has been the most encompassing one AMRC project to date. So without further ado, I will hand you over to James. Thanks very much.
Thank you, James. Good morning. So my name's James Lindsay. I'll be giving you the sort of run through on Project ELLI today. First thing I want to do is hand over to Rab Scott, who's going to give us a little talk about how the AMRC has developed over the last few years.
Thank you, James. Thank you, James. As James Fudge of the MTA, to whom we're very grateful for hosting us today, said, I've been with the AMRC since 2001. So actually, this year is our 20th anniversary. And it's really a question of what's changed in those 20 years. And the answer is not a lot in the global scheme of manufacturing. But the underlying technologies have changed beyond recognition. Throughout the life cycle in manufacturing, the design process now gives such an impact to the whole life cycle of a product, of a process, of a system. We've now got different ways of manufacturing. We're really looking at composite materials. You're looking at additive manufacturing. So you're looking at advanced casting technologies. Subtractive processes, traditional machining, which is where the AMRC came from and what Sheffield is famous for, has changed beyond recognition. Productivity has really increased tremendously in there. We're now getting automated assembly, not just within the automotive sector, which is where it really had its birth, but it's now coming across all manufacturing sectors. And these are linked together within a smart factory and within a smart supply chain, which allows the inspection, the validation and testing of all the parts of the jigsaw at all parts of the process. And it's really through this value chain of manufacturing that we're now seeing 3 threads emerging. And those 3 threads are really where the next 20 years lie. And that is within the sustainability agenda, the productivity agenda, and the digitalization agenda. Now, if we move on to the next slide, then what we can actually see is that productivity is all about doing more with less. It's improving productivity by improving quality, removing rework, getting things right first time. And we do that through the adoption of digital technologies. Yesterday, if you listened to Jürgen Meyer, the author and the leader of the Made Smarter program and the producer of the Made Smarter review in 2017, digitalization is here. You cannot ignore that. But if we embrace it, then we will really improve the productivity in the UK. We'll improve the productivity through the adoption of industrial digitalization technologies. And if you'd come to the AMRC stand at MACH in 2018, you would have seen a number of those IDTs. You would have seen additive manufacturing components. You would have seen augmented reality and virtual reality, the use of machine learning and artificial intelligence to improve the decision-making of the manufacturing process. And all of these technologies are really driving the sustainability agenda. Digitalization is an enabler to improve productivity and to improve sustainability. But sustainability isn't just about being green. There's a huge drive towards net zero and the environmental sustainability. But there are other aspects of sustainability as well. If you look at the World Economic Forum, economic sustainability is as important as environmental. We need shared prosperity. If something is going to be cost effective, then that will allow us to really embrace these new technologies. But perhaps most importantly of all, the social sustainability. We need opportunities for all. Equality, diversity, and inclusion is becoming as critical component of manufacturing moving forward as digitalization and productivity. We've got a tremendous resource base out there in the youngsters, the engineers of tomorrow. We've got a tremendous resource base out there of the engineers of today. We've got to capture their knowledge, transfer their knowledge, and really multiply the opportunities that sustainability will bring for us and provide us with the future planet that we want to live on. So today, James is really going to take us through the components of Project ELLI, weaving the digital thread together, understanding the different additive components, the additive manufacturing components, the machine learning, the different processes, manufacturing processes that we bring together by breaking down the silos of opportunity and embracing them together. So over to James for the technical insights behind ELLI.
Great, thank you, Rab. So yeah, so behind Project ELLI, I think the first thing I want to touch on is that with the sustainability sort of mantra and movement forward, what we've ultimately developed as an end goal is a sustainability demonstration. Now, the key thing that I want you to focus on as I talk you through this is really the individual technology demonstrations and how those technologies can be applied to go towards that end goal of sustainability. It's not necessarily just about a vehicle and making it light and electric and cool. It's about how we develop this ongoing. So what we have here is really the start of the curve of a sustainability demonstration. So I'm going to take you through this. There'll be about 6 videos of me talking through each individual demonstration. If you do have any questions, as James said at the start, please put those in the side tab and I'll try my best to answer them when we get to the end. I apologise, my accent isn't necessarily the most enthralling, but please do try and pay attention. So the first thing I really want to talk about is that digitalization aspect of Project ELLI. So in order for Industry 4 to be an enabling tool and allow these technologies to work together, we really have to focus on capturing information from each manufacturing process and technology and using it in an effective way. So the first thing I'm going to show you is our digital twin video 1. Welcome to our Electrification and Lightweighting in Industry 4 digital twin. The idea behind using a digital twin like this is it allows us to process monitor each of the individual demonstrations that I'm going to walk you through today. So the main sort of central focus point of the entire Project ELLI is our central product, the Caterham vehicle. And the idea behind having that central product detailed out in the way that we have is it allows for each of the individual demonstrations to feed into that central product. So each demonstration I'm going to walk you through today aren't intrinsically linked to each other. However, they are interlinked via the main central product, which in this case is Project ELLI, and the digital twin. Now, the benefit to using a digital twin in this sort of a setup and a scenario is it allows us to process monitor each of those demonstrations and the individual bits of information that are coming out of them. So for instance, on the composites demonstration that we've got, this is the robotic filament winder, which is sat over in our Advanced Composites Centre. Now, I can't show you that in physical form today because it's too large for us to actually have here. But this is effectively mirroring what is happening back in that facility. So by capturing the data of the filament wind, the torque and the angle and the speed of the fibre winding, it allows us to be able to understand how well that process is being performed. It allows us to learn from that data. By learning from that data, we are then able to implement strategies to improve the manufacturing processes that we've got. By then improving those manufacturing processes that we've got, it's where we want to lean back into the sustainability piece for Project ELLI, which is what we're all sort of focusing on here. Now, following up these sort of Industry 4 technologies and using that process data to be able to improve on the way we work allows us to be able to essentially hone down on the best manufacturing processes for each product that we output. So in the case of ELLI, where we've been working on a carbon fibre wound shaft, we're able to actually improve the process speed, improve the process quality, and reduce the carbon offset of that process while we're doing it through a reduction in the amount of time that we're able to perform that process. To follow on from that sustainability aspect, we've got other aspects of digital information being fed through. So for example, on the MBE demonstration, which I'll show you later on, we're actually using that to track and monitor the measurement profiles on the robotic program as it's running through its inspection process. So using that inspection process data, what we're able to do is effectively monitor how that inspection process is performing offline, which means that we are able, as effectively a maintenance team in this scenario, to track and understand how each of the components that's been inspected by that is running through, and we can then begin to see tracks and trends in the way we are running these operations, which then further allows us to be able to improve on those processes again and hone down on where we think some of these various defects may be. Yep. So I think that the key thing to touch on there is Industry 4 is an enabling tool. So having that level of process data allows us to look at aspects like machine learning and AI to be able to improve these processes on the fly. We can go into digital twins at great depth, but I don't think it's really worth our time spending a lot of time deep diving into the aspects of digital twin at this stage. However, it doesn't need to be as glossy and as visually representative as we see here. The key thing is understanding that process information coming out of the manufacturing processes and using it in a most effective way. So the first thing I'm going to take you through as a next step is the electrification side of it. So here we're looking at an intelligent workbench assembly, and we're looking at battery pack assembly. So if we open up video 2. So this is our intelligent battery assembly workbench. So this was developed by our remote facility over in Preston. So the engineers that we have working in Preston is effectively a satellite site, an extension of the work that we do here at Factory 2050.
However, they have a distinct focus on battery cell and battery pack manufacture and assembly processes. So the idea behind this workbench station is it offers us a digital passport for battery packs as they are assembled. The key thing when we're assembling battery packs is health and safety. The first thing to note when you're looking at this is it's a demonstration setup. So for instance, all of these battery cells that we see in here are dummy replicas. We didn't feel it would be safe to do this, not in a controlled laboratory environment, to have live lithium-ion cell batteries. One of the key things to note when you're building these battery packs is the measure of the charge between parallel poles. Now, one of the key things to that is the monitoring and the understanding of the power that each of these cells is producing and what that means as an entire pack. So with the workbench assembly that we have set up here and its identical sister that we have in the facility over in Preston is effectively a digital twin representation that guides an operator through the various steps of the processes. So if we cycle through, the operator is then guided through the various assembly processes and test procedures. By cycling through these test procedures, the operator is able to understand how the battery packs go together to form a module assembly at the end and track the data of these being tested through. So for instance, we've got contact resistance across the board. The idea of what we're trying to hit here is 0.125 ohms over their entire polarity. That means that we've got a consistent module, which means we shouldn't be experiencing any spikes. Now, where this ties back in is into our main digital twin, which I introduced you to earlier. So that digital twin and the data that we produce here are able to be interlinked and allow us to track each of these packs as they go through so that we're able to build up that trend of these modules being assembled over time.
Right. So looking back at the electrification side of it, the key thing that I think the guys in Northwest are working on is ensuring safety through assembly. One of the biggest problems that we currently have in battery cell manufacturing is non-consistent components coming through. It's critical for battery packs to be assembled to be as consistent across the board as they possibly can be. But we can touch on that later on. So the next thing I think we want to have a look at is onto the lightweighting elements piece. So we've got a couple of videos here which talk through the composite winding piece and the additive manufacturing and machining processes. The first one here is the digital twin, which I showed you earlier, of the composite filament winder. We have the video next, which is the desktop X winder. So I think we'll play video 3.
So this is our desktop X winder. The X winder is a very low cost filament winding solution. So what we're trying to show with this is that lightweighting and sustainability doesn't have to cost the earth. So the traditional filament winding machines and processes tend to be in the hundreds of thousands of pounds, which makes it a very, very difficult market for the majority of companies and SMEs throughout the UK to actually get into, which is why when we've done a lot of historic research and work on composite windings and lightweighting, it's been applicable normally only to tier 1s and OEMs. This is where we're looking to try and get it out into a much wider market. So one of the biggest challenges that I think we face technically is ensuring that a lot of the kit that we have is low cost enough and accessible to the majority of the UK manufacturing sector. And the X-Winder does that. So this is an off-the-shelf kit. It costs about $3,000 and it's able to wind a tubes effectively that normally or historically was only able to be done by very expensive bespoke machine tools. You can tell that it's a little bit low cost through some of the design artifacts on it. So it's been made with effectively aluminium profile solutions, a plastic mandrel and some very low cost solutions. But the idea behind this is it opens up a gateway for the small, medium enterprises to get into this aspect of manufacturing. Now, being able to manufacture lightweight carbon fibre components is something I personally view as critical for SMEs getting into the markets moving forward. The great thing about this is it's set up using G-code, and G-code is one of the first CNC programming codes, so almost anybody would be able to program it and use it. It's very, very simple, very straightforward. The idea is that historically the SMEs who would normally die away towards the end of industrial changes are able to keep going through the adoption of technologies like this.
So just to jump in there, I think that the last two segments have really emphasized the sustainability agenda with the workbench. What we have got the ability to do there is to upskill people rapidly while maintaining quality. And through that, we improve productivity, you improve the traceability of components through the production cycle. And if you'd listened to the presentation by Dave Holmes of BAE Systems yesterday, you will see that these technologies are starting to appear on shop floors. The last presentation that we saw is around the economic and environmental sustainability. We're really looking at low-cost enablement of SMEs to engage in this part of the market, and by doing so to take weight out of products, to improve productivity, and to have environmental impact. James.
Yeah, great. Thank you for that one, Rob. So yeah, just touching on the sustainability side of it, we've got another lightweighting demonstration here. So this is the capture of the digital twin of the additive manufacturing, and I'm going to show you the next video, which will take us through some of the additive processes.
So here we have our topology optimized additive manufactured components. So as a part of the lightweighting philosophy we've approached with ELLI, we've been looking at various routes through lightweighting of traditionally manufactured components. Now, the idea of looking at these on an individual basis was we wanted to focus on the original prop shaft of ELLI. Now, this as a component off the Caterham weighs 5.2 kilograms and is steel welded to cast and machined yoke components, and this is where we saw one of the biggest potential opportunities. This is an inertial component, which means it's a rotating mass on the vehicle. Now, to my mind, on an engineering level, when I want to talk about mass reduction, if I can get mass reduction on an inertia component, I can save much more overall in terms of efficiency than I could do normally through just lightweighting in general. And that's where we've come down this route. So as a sort of philosophy, additive manufacturing tends to start with polymer. So what you can see on the Formlabs 3D printer behind me is effectively 3D printing these components. And the idea behind using 3D printing polymer is it allows us to prototype components before we proceed to full manufacture, which means we can effectively understand how these components are going to behave when they're printed. We can understand how these components are going to behave when they are being post-process machined. But the real sort of starting block with it is the traditional component. So we start with a cast component. This is machined to specification. We then run it through some generative design optimization. So here we're looking at printing in titanium as opposed to steel. this gives us a strength and weight benefit, because it means that we're able to reduce the amount of material that's in it. Now, getting that maximum material utilisation is one of the core aspects of sustainability for us. Now, what we end up with are these titanium components that we can see here. Now, the additive manufacturing process isn't in itself the most sustainable process in the world, and that's one of the key things that we need to work on, is how do we get sustainable manufacturing through the implementation of technology which at its core isn't actually that sustainable. And we're trying to promote different aspects of sustainability within that. So we've got our 3 core principles of economic sustainability, social sustainability and environmental sustainability. And through using processes like additive manufacturing, we can look to gain improvements on each of those in various ways. Now, the outcome of that was the carbon fibre and topology optimised prop shaft. So this was effectively built by the additive manufacturing team and the composite filament winding team, which I showed you, so on the low-cost filament winder. So what we end up with is a component that has a total mass of 1.7 kilograms at the end. And that's around a 60% total mass saving. But to go back to what I mentioned at the start, if we've got that on an inertial component, what we're actually saying is we require 60% less energy to spin that component through the driveline. Now, if we're talking about going into electric machines manufacturing, the key thing that stops an electric machine being 100% efficient is the mass of the driveline components that it has to spin. So the lighter we can get these, the more efficient we can have a motor. And then through implementing these technologies in manufacturing processes, we can hope to improve the efficiency of those baseline manufacturing processes, which means that in the long run, if we can develop CNC machines which have these sorts of components internal to them, we have lightweight gear sets, we have lightweight rotating components, we can actually have a much more sustainable machining process. So traditional machining processes like these on a cast component, we would actually be able to improve the efficiency of this as a process overall.
Great. So I think that the key thing to take away from that is it's about the application of the technology again. So when we talk about using additive manufacturing in other processes such as subtractive machining, what we're talking about is, can we look through the initial manufacture of those CNC machines to improve, say, the gear sets or the rotating components within that, so that we can effectively have a much more efficient overall machine, which can then in turn lead to a reduction in the cost and the energy usage that it requires to perform a traditional process. So the next thing I think I'd like to have a look at is about the machining processes. So this is the digital twin of our full Monty machine tool. So you might have seen this or heard of it before. It's effectively a retrofitted Cincinnati H5 machine tool with a series of sensors on it. This was a sort of show as to how we could break some of the barriers of Industry 4 going forward with a more legacy machine that was as capable of running as a brand new machine tool would still be. And the video that we're going to show you is about some lightweight aerostructure components. So if we can look at the next video.
This is our advanced lightweight machining demonstration. So this is focused around aerostructures and nested pockets of machining process. Now, this is more of a machining strategy as opposed to something which is directly applicable to the main product, but it ties in massively to the lightweighting aspect and the sustainability front for machining. So We have attempted to apply some of the learnings from that on the motor bracket that we inspected on the model-based enterprise demonstration. However, we haven't been able to go as far as we were with the aerostructure components, which I'll give you a bit more information about. That is in our long-term plan. So, the aerostructure components have focused on thin wall, lightweight machining of nested pocket structures. Where we've come around to this from is the traditional manufacturing method for this is to go for square pockets. Now, the idea behind square pockets is that they are thought of as being one of the most lightweight components that we could get, whilst also retaining the most structural rigidity. And our technical lead in this, Dan Smith, felt that he was able to do more by investigating the nested pocket structures. So the three primary types we look at are square, hexagonal and triangular. And I can't show you this, and it's really difficult to explain how much of a weight difference there is in picking these up to you through camera. But what I can tell you is that the overall weight saving between the squared structure and the hexagonal structure on a 2mm wall piece is 28%. Now, what that means in lightweight aerostructures is a gigantic saving in the CO2 emissions of a plane at current. But really, I think the most interesting thing about this was what we actually found while performing the machining operations. So, in performing the machining operation for the hexagonal component, because the tool path is actually a much more circular path, the degree angle here is 120 degrees, which means that the tool has a much more gentle approach path as opposed to the 90-degree bends that you expect it to do. That means that the machine doesn't have to slow down as much while it's performing the operation, and it's able to actually perform this machining operation more accurately, faster, and produce lighter, better quality components out the back end of it. And that's been a real big win for us in terms of understanding how nested pocketed machining could be implemented going forward. The two pieces that we see at the front here were really Dan's attempts to work out how thin we were able to go. So one of the things that we know when we look at these thin wall machines is because the straights on the hex are much shorter, we actually have a greater wall stiffness, which means that as the tool is performing its profile, we get less deflection on the component, which means we get a much more consistent wall thickness throughout the entire component. In this case, that means we were able to do down to 1 millimetre of wall thickness consistently. That's something that when we tried with the triangular, we just ended up going straight through the wall because the distance is so far that the flex on the wall is so much that the tool actually breaks through. So that's where we're seeing the biggest sort of leap on this for now. But there is a lot more work to do on this going forward, and I think what we'd really like to do is implement this as a strategy going further into ELLI and looking at more components than just the motor mount, which we've done in this year's case.
So for me, what these last two presentations have really brought home is how you've got to look at the manufacturing process as a complete system. You cannot look at the individual components in isolation because they're all linked to each other. And it's that system view that really allows the drive towards sustainability, the drive towards digitalization and productivity out the back end to really come through. James?
Yeah, definitely. Like Rab says, it's about using these technologies in combination with each other to get to that end goal. You can't just focus on a single strategy or single methodology and hope that that will get you the majority of the way there. So I think to sort of move on from this and talk a little bit about how we tie in together, we want to look at Industry 4. So piece that we're going to show you here is model-based enterprise. So this is more about quality management and ensuring that we have a single source of truth for components as they're running through their life cycle. Now, I would personally view Industry 4 as that enabling technology, and that's what ties all of these individual technologies together in that final product, and that is how ultimately we get to the end goal of a sustainable future throughout environmental, economical and social aspects. So if we have a look at the final video.
So what we have here is our model-based enterprise demonstrator. So model-based enterprise, it's all about improving the single source of truth of information. It's about ensuring that we have the correct information in the correct place at the correct time. So one of the problems that we often find in manufacturing is that we have so many different quality management systems and different documents for effectively tracking a product or a part through its entire life cycle. And model-based enterprise aims to reduce that into a single source of truth. So what we have here on the screen is our AMRC developed interpretation and application for that. So as you can see, we've got method statements, risk assessments, driving licenses and cost for the individual component and its process. So what we have is effectively a setup with a 3D model in the background with all of the relevant geometric and dimensional tolerancing information that we need on that component, plus some of its associated risks that are detailed in the risk assessment and the method statement for it. So what we effectively generate using this plugin is a 3D PDF. So while that's loading up, it effectively brings up that component into a 3D PDF. And what we then have from that 3D PDF is a model which we're able to move around in space. We're able to inspect the individual bits of information that are on that. So we can see here we have some measurement information, we have some tolerances for this as a process. Now what that does is gives you information as to how this inspection process should be carried out, what we would expect to see. What we have as an additional attachment to this is, say, in this instance, a list of equipment. So this is attached to that single source of truth. It's within that model. So this is being generated by the model as we go through and cycle it. So if we then go back onto here and then click through our inspection process, so this is where using an automated solution is enabling us to capture that information and data and then feed it back out into that 3D PDF, thereby creating a loop for that single source of truth. So if we have a look through here, we've got pathways. What do we want to measure? So I'm going to measure all components, all selections within that, and then we have a lightweight machine component which we've developed specifically for ELLI that we're going to inspect. So as we then cycle through that, the inspection process is effectively capturing that information while the operation is running. All of that information is then being fed intravenously back into the model. So at the end of this, once it's generated the report, we will have the GD&T of that measured component. So what we then have when we attach our report is a new 3D PDF with a series of information on it here, but the attachments are where we excel. So now you'll notice that we have captured images of it performing that inspection process. So if we click onto that one, we can bring up a capture image of it taking a picture of that component. If we go on to GDT, it actually brings up the measurement information and the tolerance that we wanted to see as it's running through that process. And then the really important thing that we get out of this that really ties in that single source of truth is the inspection report, which is detailed here. So we have an automated inspection report which is directly measured from that component, and we can see that we've failed on a measurement here. So therefore we know that that component is out of spec and out of tolerance. Now all of these bits of information, we could then go back and edit these within the actual part and model itself. So that's what I mean by containing all of that information within that single source of truth. It's all automated. It gives us that clamp down.
So I think the biggest thing to note with this automated inspection process and MBE is it's about improving the efficiency of our quality management systems and encapsulating information in a single, as I keep saying, single source of truth. But by having all of that information, we're able to do away with a very, very large paper trail, which plagues manufacturing. And really, this is about ensuring we keep as much information in that single model as we possibly can do. Now, if we're able to keep that through the life cycle of a component, so think about potentially sensors embedded into that component, we can use this to feed digital twins consistently throughout the life cycle of component. But I think that sort of brings us to an end of the individual technologies that we've talked through today. So the point that I would like to stress here is we aren't finished yet. We are only just beginning on this sort of development scale and the use of ELLI in sustainability in this way. Really, we've got a roadmap over the next few years, but ultimately, I don't think we ever see us finishing this. It's going to be a continual development because if industry is always going to be evolving, therefore ELLI will always be evolving alongside that. So what you've seen today is a bit of a teaser looking towards 2022, and we're going to have a focus on some of these components going forward. But that sort of brings us to the end of the presentation here. Rab, do you have anything more that you'd like to add at this stage?
For me, we've got to think differently, and I think that the last technology we showed, the model-based enterprise, the single source of truth, the digital thread that weaves its way through the life cycle of a product, of a process, of a component, really highlights what so much of Industry 4 is about. You know, we want to remove non-value added activity, and quite a lot of the time inspection is of value, but the process of inspection is non-value added activity. And the fact that we've automated it using relatively low cost solutions is critical. And in fact, this afternoon, you will be able to hear from the Chief Automation Officer of the MTC, one of the other high value manufacturing catapults, looking at automation for SMEs. These are technologies that we must start to embrace. These technologies that allow us to change the way that we work is where the future lies. And I think with that, we would encourage you that this is, as James said, this has been a teaser. Come along and see it, come along and touch it, come along and feel it next year at MACH 2022.
All right, that's brilliant. So thank you all for listening to us today. I think we'll open the floor to questions. Apologies you've had to listen to my voice for the majority of that. There will be a recording of this if you did fall asleep, so feel free to watch it back if you did miss anything.
And I think we now hand back to James.
Gents, thank you so much. That was really interesting, and I think really well put across for something that's made as a demonstrator and a live demonstration of technology. To actually try and convey that over this media is difficult, but I think you did a really good job. So thank you both so much. Really appreciate that. Just a reminder to people, you can put questions into the question box. We have had quite a few through. The first one that we had, it's kind of a two-part question. One is, obviously you've got this with ELLI, the application is obviously in the Caterham car, but what other applications do you see this being used in? And when do you see these technologies being used in the mainstream?
I'll jump into the first part. I mean, some of the technologies that we showed, like the workbench for the battery pack assembly, they're already being tested in industry. They're already out there. So these technologies and the model-based enterprise, they're beginning to get adopted. So they're already out there. Some of the other ones, the more technical ones around the mass reduction, I'll let James answer.
Thank you. So yeah, we are seeing them get out there a bit. Composite manufacturing and filament winding has itself really taken off, and that's going down its own path. But additive manufacturing is one which is a little bit different. So I think the main sort of challenges around additive manufacturing adoption are actually the design for additive manufacturing and the understanding of these processes. So it's not just about being able to take these technologies and run with them. We have to educate ourselves. We have to educate the next generation of engineers to be able to use these technologies and adopt them properly going forward. I think looking at it from a sector sort of perspective, it's definitely not just automotive. These technologies are completely agnostic. So we could look at almost any transport media. We could look at CNC manufacturing, the actual machines themselves. You know, we kind of view this technology adoption as something that everyone has to take up. And by everyone being able to take it up, then we're able to build on that final sustainability goal and output.
Just on that, additive manufacturing isn't just constrained to the manufacturing sector. We're seeing additive manufacturing be used in construction. We're seeing it where they're printing houses. We're seeing it being used in food, where they're printing bespoke food. We're seeing it being used in retail. There are a couple of places in the world that you can go and get your foot scanned and they will print you a trainer shoe bed. We're even beginning to see it being used in biomaterials, where they will be printing things that actually interface with the human body. You know, the world of additive manufacturing is absolutely going to be massive.
And I think leading on from that, I mean, our next question says, amazing technologies, thank you. How would an SME, or what's your advice to an SME to be able to affordably acquire and deploy these sort of technologies in their factories? Where would they start?
If I jump into that one, James, I would say, come and press it, come and touch it, come and feel it. And that's really what the catapult centres are here for. The catapult centres exist across the UK, all the way from the National Composite Centre down in Bristol up to the Advanced Forging Centre, Forging and Forming Centre in Glasgow. And we're there really to de-risk the engagement of SMEs and larger companies with these new technologies. We can demonstrate the technologies, we're neutral, unbiased. We've not got anything to sell except for the benefit of UK manufacturing. So engage with your local catapult centre, I would say, is one of the best places to start.
I'd also touch on the 5-day assist programme as well, that runs across the catapult centres. So that would be a funded 5-day project that we're able to help on. Like Rob says, touch base with your local centre. If you don't know who your local centre is, feel free to drop us an email and we can send that out as well.
Great stuff, thanks both. The next question we've had come in specifically around additive. Have you looked into reusing the titanium powder into castings for less safety critical components?
The short answer is yes. The long answer is not fully. So we've started looking at the reuse of materials. However, we're still at a very junior stage whereby we're trying to get the quality of the virgin material up to standard at the moment. If we can do that, then it gives us the initial route entry for additive in a lot of places. But to answer on that, we haven't started on it fully. It is something that's on our long-term roadmap, but it's a difficult challenge in itself to understand what those material properties will be like.
Sure. The other questions we've had in have come around some of the other areas. One of the questions was, how quick is it to set up and program the robot to inspect, if you're comparing that to a CMM measurement system?
That's a good question. So it depends on the inspection process, obviously. So that was set up using a Cognex camera vision system, which runs through a National Instruments computer. So it's fairly low cost and readily accessible technologies. Programming those takes a much shorter amount of time than it does to program a CMM. I don't have the actual data and the actual time that it was taken, but we can certainly have a look into that going forward.
I'm going to take the next two questions together, so it might take me a little minute to get through these. But one of the so the question was, are you speaking to niche vehicle manufacturers about the good work you've done in terms of the electrification piece, as there's a growing industry of reuse and conversion of classic and kit cars to electric? And the other question that's come through, which is slightly related, is when do you think we'll see these technologies implemented on vehicles available to the general public?
So the first part of that question, we are interacting at a very high level initially with the niche vehicle market. I won't go into detail as to who that's with, as I'm not sure we're in a position to be able to do that at the moment. However, it is something we are working on. Our ultimate end goal, as I've sort of alluded to it with all of this, is we want the technology to be agnostic, and primarily the niche vehicle market tend to approach us when they see something like this. So that's how we sort of view it going forward. I will let Rab answer on the where we sort of see it being implemented further in the future.
So these technologies exist today, but quite often they are perceived as being high cost. I think that what we've shown today is they needn't be high cost, but you've also got to have the enterprise systems behind it to be able to encompass the life cycle, to be able to capture that data and reuse it. If you just implement any of these solutions as a single point solution, which we are seeing already being done, then you will gain benefits, but you won't gain as much benefits as if you integrate the system.
Sure. And do you think there'll be an impact on affordability of that as well, in terms of when these technologies become, I suppose they'll move more into the mainstream with affordability coming down?
Completely, yes. We've seen the general industrial digital technologies, you know, AR and VR in the late 90s. That used to be the realm of the large OEMs only because of the cost. Now, you know, we've got VR, we've got AR on our phones, we've got VR headsets in the living room. As the technologies mature and as the demand grows, the cost will come down. There's also the aspect of, as we get to embrace cloud technologies more, we will have greater access to a more diverse digital ecosystem more quickly and at reduced costs. So you won't have the large capital costs that traditionally have been perceived for a lot of these systems.
Sure. Well, brilliant. I think we are almost out of time, so I will end there with the questions. But thank you both so much for being here today. It's been really appreciated. And just a reminder that a recording of this presentation will be available on the MACH website, hopefully within the next week, but it might be a little bit longer than that. We will email out to all delegates and remind you of that. And a reminder that you can come and actually see the car and all these technologies we've talked about at MACH next April. we've got a few more sessions coming up today. As Rab said, we have simple steps to automation for SMEs, which is a panel discussion, which is at 11:30, so in a little over half hour's time. And this afternoon, we have Howard Mitchell, who is the head of innovation at High Speed 2, talking about supply chain and innovation. And then tomorrow morning, we have Stephen Jeffers from Siemens talking about decarbonisation, which is our 10 o'clock session tomorrow. So if you want to join us, please do so. Register via the MACH website, same way you did for this session. I'd also advise you to check out the A to Z because it gives you a good idea of some of the exhibitors that will be at the show, and you can start making contact ahead of time. There's also a feedback form that will pop up at the end of this, as well as be emailed to you. If you could take 2 minutes just to fill that out, we'd really appreciate it. It just helps us guide the next sessions as well as content for the live event next April. So finally, thanks once again to James and Rab, and I wish you all a pleasant day. Many thanks.
Thank you.
Thank you, and stay safe.